right, so looking at section 1.4, number 3 notes. So our learning targets for today is that we want to be able to find constants. The constants we want to find should be able to form a continuous function. The other thing we want to be able to do is to use the intermediate value theorem correctly. All right, so in example 6, it says find the constants a and b such that the function is continuous over f of x. So let's look at this first problem. This problem is saying that we have y equals 3x squared. What kind of shape is that? Parabola. And we're only graphing the parabola when x is less than or equal to 2. Then we're supposed to switch, and we're supposed to be graphing y equals ax minus 2 when x is greater than 2. But the thing is, I want to be able to graph the parabola and then go directly into the line. So I want them to be continuous, connected. I want you to think for a minute how we could do that. How could I find the a value that would make it so that the parabola connects to the line? Casey? Okay, so let's plug in 2 here. If I plug in 2 here, 2 squared is 4 times 3 is 12. If I plug in 2 here, though, I can't get an answer. So what am I going to do? Okay, so we're going to say then that this function here is y equals ax minus 2. So he's saying that if I plug in 2 for x, I want to be able to get 12 for y. And that's correct. That's going to work. So solving this, I'm going to get 2a equals 14, and so a is going to equal 7. So that's the value that's going to make this continuous. I'm not sure if I've shown you this yet, but you can graph piecewise functions on your calculator. Let me show you how I could now graph this. I go to y equals, and I'm going to tell my calculator to graph 3x squared, but I want to divide it up. I only wanted to graph this when x, I go under test, is less than or equal to 2. And then I'm going to come down to my next one, and I'm testing this, so I want a to be 7. So I want the calculator to graph 7x minus 2, but I wanted to divide it up, only graph it if x, go to your test, is greater than 2. So I'm checking this. I want to see if it's connected. Now where is it that they're going to check? All the way, they're going to connect all the way up at 12. So I'm going to have to change my window so I can see that high up. I'm going to make it like 20 for y. Okay, so here's my function. I have the parabola, and then it switches to the line. Now it doesn't look connected there, does it? But let's look at the actual function and why that's going to happen. Let me change this. I'm going to make this so that it's greater than or equal to, because it should still be graphing that, you know, but it's just going to have a closed dot. So watch, let me change this. Okay, now let's graph it. Okay, the calculator is not doing a very good job of doing this correctly. Look at your table. See though how at 2 it's going to be connected because we got the same answers for y for both of the functions. It's just that the calculator it's not connecting that well the way it should, but it really is connected there. Alright, let's go on to letter B now. So let's think about what this means. We're graphing y equals 3, but only if x is less than or equal to negative 2. How does that line look? Next, how does the line y equals 3 look? Is it a vertical line or horizontal line? Horizontal line, yeah. So we're going to be, when x is less than or equal to negative 2, we're going to be up here at 3. And we're only graphing that line when x is less than or equal to negative 2. This we don't know. So we have some line, y equals ax plus b. We don't know what a is. We don't know what b is. But we wanted to connect with this part of the function. So this part of the function is saying that when x is greater than or equal to 1, we want to graph the line y equals -3. That's going to look like this. So the question is, what do a and b have to be to make this a continuous function so that I can trace it without lifting my pen? I'm going to give you a couple minutes to think about it, and you can even talk to your group if you'd like. Right. Anybody willing to kind of tell me what you're doing, or even if you're not all the way finished? What are you doing back there, Michael?
You can use a slope.
Okay.
Big line.
And how are you doing that? Like, how do you know 2 points?
The -2, 3, and the one -3.
All right. So why is it helpful to find the slope?
Because if you know it's continuous, you know there should be a line.
Yeah. A is going to be equal to the slope, isn't it? So he's right. We can just find the slope here. So to find slope, m, also a, I do 3 minus -3 over -2 minus 1. That gives me 6 over -3. And so therefore a is going to have to be -2 to make that work. Okay? Were you able to find the y-intercept as well, Michael?
You gotta pick either one of those points.
Right. So right here, I'll take the top point. I'm going to plug in for y. We know the slope. We know the x value. So we have 3 equals 4 plus b. b equals -1. So there we go. We've got a and b. Did anybody do this a different way? Nobody could think of a different way to do it? Let me show you a different way, because I want you to kind of understand 2 ways of doing it. If I look back here, I have 2 points, don't I? So I can plug the first point in here. I can do 3 equals -2a plus b. See what I'm doing? I'm plugging in for x and I'm plugging in for y. Then I can take my other